Hello. Hello and welcome to this video. As we were going through the standard library and I gave 6 videos on regular expressions. So we will stop with regular expressions now and we will move with something called Difflib in the standard library. So we are going in uh, the order of table of contents. So we will do the boring read through of the documentation here. And then once it is done, I will show you some examples. There are some examples given in this as well. So without further ado, let's get started. So Difflib is a library for computing deltas. If you want to see the source code, it is given here. Okay, so we can go through this if you want. And let's go through how this works. So this module provides classes and functions for comparing sequences. It can be used, for example, for comparing files and can produce information about file differences in various formats, including HTML and context and unified diffs. For comparing directories and files, see also the file CMP module. So the class which is called sequence matcher. This is a flexible class for comparing pair of sequences of any type, so long as the sequence elements are hashable. So that means strings will work, integer will work, tuples will work. The basic algorithm predates and is a little fancier than an algorithm published in the late 1980s by Radcliffe and Oberschelp under the hyperbolic name Gestalt pattern matching. The idea is to find the longest contiguous matching sequence that contains no junk elements. These junk elements are ones that are uninteresting in some sense, such as blank lines or white space. Handling junk is an extension to the Radcliffe and Oberschelp algorithm. The same idea is then applied recursively to the pieces of the sequences to the left and to the right of the matching subsequence. This does not yield minimal edit sequences but does tend to yield matches that look right to people. And now we consider the algorithmic complexity. The basic Radcliffe-Oberschelp algorithm is cubic time in the worst case and quadratic time in the expected case. Sequence matcher is quadratic time for the worst case and has expected case behavior dependent in a complicated way on how many elements the sequences have in common. Best case time is linear. Automatic junk heuristic. Sequence matcher supports a heuristic that automatically treats certain sequence items as junk. The heuristic counts how many times each individual item appears in the sequence. If an item's duplicates after the first one account for more than 1% of the sequence and the sequence is at least 200 items long, this item is marked as popular and is treated as junk for the purpose of sequence matching. This heuristic can be turned off by setting the auto-junk argument to false when creating the sequence matcher. That was the description of sequence matcher. Now we look at the class differ. This is a class for comparing sequences of lines of text and producing human readable differences or deltas. Differ uses sequence matcher both to compare sequences of lines and to compare sequences of characters within similar near matching lines. Each line of a differ delta begins with a 2-letter code. Minus space means it is unique to sequence 1. Plus space means it is unique to sequence 2. Double space means line is common to both sequences. Question mark space means line not present in either input sequence. Lines beginning with question mark attempt to guide the eye to interline differences and were not present in other input sequence. These lines can be confusing if the sequences contain whitespace characters such as spaces, tabs, or line breaks. The next class is HTML diff. This class can be used to create an HTML table or a complete HTML file containing the table, showing a side-by-side, line-by-line comparison of text with interline and interline change highlights. The table can be generated in either full or contextual difference mode. So the constructor of this class HTML diff takes tab size, wrap column, line junk, and char junk. So obviously it is the constructor. Tab size basically defaults to 8 characters, and wrap column is an optional keyword to specify column number where lines are broken and wrapped. Defaults to none where lines are not wrapped. Line junk and char junk are optional keyword arguments passed into ndiff, used by HTML diff to generate the side-by-side HTML differences. So it asks us to see ndiff. So if you want to see ndiff, we will see ndiff later. Now we look at the public methods. The first function is make_file. So it has arguments from lines and to lines, which are mandatory argument. Then it has from description to description context. Default value of context is false. Num lines is equal to 5. And then list of arguments and char set is defaults to UTF-8. It compares from lines and to lines, which are lists of strings, and returns a string which is a complete HTML file containing a table showing line by line differences with interline and intraline changes highlighted. From description and to description are optional arguments to specify from or to file column header string, both defaults to an empty string. Context and num lines are both optional keyword arguments set context to true when contextual differences are to be shown, else the default is false to show the full files. Num lines default to 5 when context is true. Num line controls the number of context lines which surround the difference highlights. When context is false, num line contains the number of lines which are shown before a difference highlight when using the next hyperlinks. Setting to 0 would cause the next hyperlinks to place the next differences highlight at the top of the browser without any leading context. From description and to description are interpreted as unescaped HTML and should be properly escaped while receiving input from untrusted sources. Then the next method is make_table, which is from lines to lines, from descriptor to descriptor, context and num lines, just like make_file. So it compares from lines and to lines and returns a string which is a complete HTML table showing line by line differences with interline and interline changes highlighted. The arguments are same as make_file method. Next we have a method called context diff, where it has two mandatory arguments a, b. Then we have from file, to file, from file date, to file date n is equal to 3, and line terminator is \n. Compares a and b, which are list of strings, and returns a delta, a generator generating the delta lines in context diff format. Context diffs are a compact way of showing just the lines that have changed plus a few lines of context. The changes are shown in a border before-after style. The number of context line is set by n, which defaults to 3. By default, the diff control lines, those with star 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 or minus minus minus, are created with a trailing new line. This is helpful so that inputs created from io.io base.read lines result in diffs that are suitable to use with io.io base write lines, since both the inputs and outputs have trailing new lines. For inputs that do not have trailing new lines, set the line term arguments to empty string so that output will be uniformly new line free. The context diff format normally has a header for file names and modification times. Any or all of these may be specified using the strings for from file to file, from file date to file date. The modification times are normally expressed in ISO 8601 format, which is the date time specification for ISO. If not specified, the strings default to blank. Now what we have is an example. So we import sys, and from Difflib we import star. So we have two list of strings because that arguments A and B are list of strings. So we have bacon, eggs, ham, and guider. Note that how they have \n hard coded in that, and then we have s2 python, eggy, hamster, and guider. And then we call sys.stdout.writeLines, and inside that we call the context diff function. We pass s1, s2. From file we say before.py and to file after.py. So you see star is before.py and minus is after.py. Then it tells line number, that is 1 to 4, and it shows exclamation mark before bacon, eggs, ham, that is these lines do not match, and guido matches, so nothing is before that. And in the second one, that is for s2 or after.py, we have python, eggy, hamster, which are not matching, and then we have guido. See a command line interface for a more detailed example. We'll see it will come, it's on the same page. The next function is get close matches. It takes an argument word, and then we have possibilities, n is equal to 3, cutoff is equal to 0.6. Returns a list of best good enough matches. Word is a sequence for which close matches are desired, typically a string, and possibilities is a list of sequences against which to match word, typically a list of strings. Optional argument n is 3. The maximum number of close matches to return, n must be greater than 0. Optional argument cutoff, which is 0.6 as default, is a float in the range 0 to 1. Possibilities that do not score at least that similar to word are ignored. The best, no more than n matches among the possibilities are returned in a list sorted by similarity score, most similar first. So we have get close matches function, and we want to find words similar to apple. And the list of possibilities are 8, apple, peach, and puppy. And it returns apple and 8. Then we have import keyword. So this keyword is the keywords of Python, okay? And again, get close matches, and we match wheel. So wheel will match with while. Pineapple does not match with any keyword. Except matches with except. So these are the close matches. That's how you use to find similar words. Now we come to NDiff. So remember our NDiff discussion here. So the HTML diff makes use of NDiff. Okay. So we look at the function NDiff. So it takes two arguments A and B. Line junk and char junk comes from HTML diff. Compare A and B lists of strings, return a differ style delta generator generating the delta lines. Optional keyword parameters line junk and char junk are filtering functions or none. Line junk, a function that accepts a single string argument and returns true if the string is junk, or false if not. The default is none. There is also a module level function isLineJunk, which filters out lines only visible characters, except for at most one hash characters. However, the underlying sequence matches class does a dynamic analysis of which lines are so frequent as to constitute noise, and this usually works better than using the function. Charjunk is a function that accepts a character, a string of length 1, and returns if the character is junk or false if not. The default is module level function is character junk, which filters out white space characters, blank or tab, and so on. So here we call the NDiff function, and we have one string of 3 lines because there are 3 \n, 1, 2, and 3. And we split these lines and we keep the ends, we supply the keep ends as true. And at the end, we join the diff and end is empty string. So if you look at this, then 1 is minus. Okay, and as we saw, minus means unique to sequence 1. So that means 1 is unique in sequence 1. Then we have question mark. Okay, now remember, question mark, line not present in other input sequence. Okay, so we have caret. Okay, we'll see where this caret comes from. All right, and then we have or. Or is plus, that is unique to sequence 2. Then we have 2 and 3, which are unique to sequence 1, and then we have 3 and mu, which are unique to sequence 2. Now we come to Difflib restore, which takes a sequence and another argument which. It returns one of the two sequences that generate delta. Given a sequence produced by differ.compare or ndif, extract lines originating from file 1 or 2, parameter which, stripping off line prefixes. So see, we call ndif and then we create a list out of that, and finally we call restore and we pass 1 or 2 to restore and give it diff, and then what it does is if you give 1, then it's printing 1 to 3, and then we have or 3 and mu if diff is equal to 2. So as you can see, the description, given a sequence produced by ndif, extract lines originating from file 1 or 2. So it will originate from this sequence or this sequence. Pretty simple function. Next we have unified diff, which again takes two arguments from file to file, from file date to file date, and so on. So it compares the list of strings, usually list of strings, returns a delta in unified diff format. Unified diffs are a compact way of showing just the lines that have changed plus a few lines of context. The changes are shown in an inline style instead of before-after blocks. The number of context lines is set by n, which defaults to 3. By default, the diff lines, those with minus, 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 plus, 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 or at the rate, are created with the trailing new line. This is helpful so that inputs created with io.io based read lines result in diffs that are suitable to use with write lines, since both the inputs and outputs have trailing new lines. For inputs that do not have trailing new lines, set the line term argument to empty string so that output will be uniformly new line free. The unified diff format normally has a header for file names and modification times. Any or all of these may be specified using the strings for from file to file, from file date to file date. The modification times are normally expressed in ASO 8601 format. If not specified, the strings default to blank. So we have the S1, S2 argument, which we had earlier, and we pass from file and to file argument along with S1, S2 and call unified diff. So it prints the before.py and after.py, minus, minus, minus for this and plus, plus, plus for this. So it shows that from the S1, bacon, eggs, and ham were removed, and in S2, python, eggy, and hamster were added. So it is the source, the first argument is source, and S2 is target. So basically what it means is that if you perform this operation on S1, it will become S2. What I mean to say is you delete bacon, eggs, and ham from S1 and add python, eggy, and hamster, then it will become S2. So this is typically used in something like Git when you do diff or you want to compute patch for a file from source to target. So the patch or Git diff tells you what has changed into the file. That is, what changes you make to the existing file to get the current status of the file. Next we have diff underscore bytes, which take a defunct A, B, and then from file and to file are there. These are all byte strings, not normal strings. Compare A and B, list of bytes object using defunct yields a sequence of delta lines. In the format returned by defunct, defunct must be callable, typically as identified diff or context diff. Allows you to compare data with unknown or inconsistent encoding. All inputs except n must be bytes. Objects, not str, works by losslessly converting all inputs except n to str and calling defunct ab from file to file, from filelet to filelet, n and line term. The output of defunct is then converted back to bytes. So the delta lines you receive have the same unknown inconsistent encodings as a and b. Then we have the two functions which we have seen earlier, the isLine junk and isCharacter junk. So it returns true for ignorable lines. The line, that is, this is the argument, is ignorable if line is blank or consists of a single hash. Otherwise, it is not ignorable. Used as a default for parameter line junk in NDiff in older versions. Then we have isCharacter junk. It returns true for ignorable characters. The character ch is ignorable. If ch is space or tab, otherwise it is not ignorable. Used a default for parameter char junk in NDiff. So if you want, you can look at this link, which is in Dr. Dobbs' journal. So you can go ahead in this link, which is quite involving and includes a lot of assembly code. And let me see if you can work with this. So it is not, yeah, you can look at the C code also. Okay. So I'm not sure if the C code will work without the assembly code. I have never seen this. I'm not going to study the assembly code, but there are two C programs. So if you are feeling adventurous, you can go ahead and study. Otherwise, maybe I'll try to find pattern matching stuff. Okay, and if there's the actual algorithm is the diff algorithm. So you can look at the diff command and study its source code to understand the algorithm. Perhaps I will show you in the next video the diff source code. Now we look at the sequence matcher objects. So it has a constructor sequence matcher is junk none, a and b in testing auto junk is equal to true. Optional argument is junk must be none or the default, or one argument function that takes a sequence element and returns true if and only if the element is junk and should be ignored. Passing none for is junk is equivalent to passing lambda x colon false. In other words, no elements are ignored. For example, pass lambda x in space \, tab. If you are comparing lines as sequences of characters and do not want to sync up on blanks or hard tabs. The optional arguments A and B are sequences to be compared, both default to interesting. The elements of both sequences must be hashable. The optional argument autojunk can be used to disable the automatic junk heuristic. Sequence matcher objects get three data attributes. Bjunk is the set of elements of B for which is junk is true. B popular is a set of non-junk elements considered popular by heuristic if it is not disabled. B to J is a dict mapping the remaining elements of B to a list of positions where they occur. All three are reset when B is reset with set sequence or set sequence 2. Sequence matcher objects have the following method: set sequence A comma B, set the two sequences to be compared. So sequence matcher computes and caches detailed information about the second sequence. So if you want to compare one sequence against many sequences, use set sequence 2 to set the commonly used sequence once and call set sequence 1 repeatedly once for each of the other sequence. So we have set sequence 1 and set sequence 2, which sets these sequences to be matched. And then we have find longest match. So we have a low is equal to 0, A low 0, A high none, B low 0, B high none. So what it does is it finds longest matching block in A, and it takes the slice of A between A low and A high, and then B low and B high from this B. That is the sequence which we have set using either of the functions or set sequence. If is junk was omitted or none Find longer matches returns I, j, k such that A I colon I plus k is equal to B j colon j plus k, where A low less than equal to I less than equal to I plus k less than equal to A high, and B low less than equal to j less than equal to j plus 1 less than equal to B hi. For all I j k meeting these conditions, the additional conditions k greater than k prime, I less than I prime, and I is equal to I prime, j less than equal to j prime are also met. In other words, of all maximal matching blocks, return one that starts earliest in A, and of all those maximal matching blocks that start earliest in A, return to the one that starts earliest in B. So for example, here we have the strings ABCD and ABCD, and we say that A low is 0, A high is 5, B low is 0, B high is 9. So it gives us A is equal to 0, B is equal to 4, and the size is equal to 5. So notice that there is a space here, so it will match with this. Excuse me. If is junk was provided, find the longest matching block to is determined as above, but with the additional restriction that no junk elements appears in the block. Then that block is extended as far as possible by matching only junk elements on both sides. So the resulting block never matches on junk, except as identical junk happens to be adjacent to an interesting match. Here is the same example as before, but considering blanks to be junk, that prevents space ABCD from matching the space ABCD at the tail end of the second sequence directly. Instead, only the ABCD can match, and the matches the leftmost ABCD in sequence. What you see here, the difference in output here, B is equal to 4, here B is equal to 0, because space was ignored now by this lambda. If no blocks match, this returns A low, B low, 0. This method returns a name tuple match A, B, size. So I think I will stop here, or let me complete this class and then we'll see. No, I think we can stop here. So in the next video, we will start from this get matching blocks. Okay. So I know this is boring, but going through documentation tells you so many things which you just can't get by Googling or reading through Stack Overflow answers. So I'll see you in the next video, and in the next video I'll complete this and we'll go through these examples, and plus I will run some additional examples. So we should be easily able to finish this in next video, and I'll end this video here. So thanks a lot for watching the video. I hope you are enjoying this playlist, and I'll see you in the next video. Till then, enjoy.